Now we'll demonstrate using the VBA Performance Calculator to show optimum placement for the amplifier. First, you're going to log into the Actelis website. If you have user ID already, you can log in, click on My Actelis, and complete the customer registration form if you don't have a login, and a login will be sent to you by email. Otherwise, log in. When you get logged in, click on Support, and then Performance Calculators. Here's our Broadband Rate and Reach Calculator for the Gen 3 ABA VBA product. Here's the ABA calculator for the Gen 2 product. For now, we're going to go to the Broadband Rate and Reach Calculator.
Now that we're in the Broadband Rate and Reach Calculator, we can come over here to the product line. We want to go ahead and select VBA. Under VBA type, we can either choose the VBA or the ABA. ABA is for ADSL, VBA is for VDSL. For now, we're going to go ahead and try to use the ABA. Over here, you can select your target SNR margins for your downstream and upstream rates. If you have current information without an amplifier, you can enter it in here if you'd like. This will give you a better estimation of where you should place it and what you can expect. In this section, we want to enter in the footage from the D-slam all the way out towards the CPE. So our test loop is going to be 2,000 feet of 26 gauge, 4,000 feet of 24 gauge, another 6,000 feet of 24 gauge, and 1,000 feet of 22 gauge. We're going to go ahead and leave the cable plant encoding default. So come over here and create your placement graph. So now that the graph is loaded, let's go over what these numbers mean. In blue on the left-hand side, this corresponds to the downstream data rate. In green on the right-hand side, this corresponds to the upstream data rate. On the bottom, this corresponds to the placement for the D-slam in kilofeet. So say for instance we placed the ABA somewhere between 6,000 feet and 8,000 feet. If we go up here, we can expect to achieve about 14 meg or better. If we look at this rate on the upstream, they're about the same, probably about 1.2 meg. If you come down here to the dotted blue line, this corresponds to what you can expect to get without the amplifier. Now if we had a bonded circuit, we can go ahead and click here on bonded results. As you can see, the placement will still be the same. It's just your data rates will change. So now for grins, let's go ahead and type in a VBA product. Let's take off the bonded results. I'm going to come over here to VBA type and select VBA. If you have vectoring enabled, go ahead and keep it as yes. If not, select no. For now, we're going to use no. Under your spectral mode, you have the choice of either 12A or 17A. We recommend using 17A at the moment. We do support the other 8X profiles, we just haven't built it into the calculator as of yet. We're going to go ahead and leave the downstream and upstream SNR at 6 dB. We're going to change our footage from 3 kilofeet of 24 gauge and let's just say 1.5 kilofeet of 24 gauge. Let's delete the rest and click Create Placement Graph. On the bottom here, we have our placement, left, downstream, right, upstream. So let's go over this. Our blue dotted line represents what you can get without the VBA. In this case, you're looking at about 32 meg. Now, if you were to place the VBA somewhere between 3 and 3.75 kilofeet, you could probably expect to get about 41 meg or better. That's a pretty big improvement. Now, if you moved it closer towards the CO, the D-slam end, and placed it, let's say, between 2,225 feet, 2,250 feet and 2,750 feet, a little over 8 meg on the upstream. But your downstream rates won't be as good. So let's go over that. Let's explain that. If you move towards the D-slam or the CO side, the VBA will attempt to get more upstream. If you move it towards the CPE side, the VBA will attempt to get more downstream. So depending on what you're after, you have a range of placement. So if you were to place it right here, between 2.75 kilofeet and 3 kilofeet, you can expect to get the best of both worlds.